UJT transistor.
A single junction transistor, UJT, is a type of three-terminal semiconductor device that can be used in timing and triggering circuit applications to control and switch triacs and thyristors used in AC power control systems. Like diodes, single-junction transistors are made of separate N-type and P-type semiconductor materials, with a PN junction, hence the name single junction, forming in the main N-type conducting channel of the component. Although the single-junction transistor has the name transistor, its switching characteristics are very different from those of bipolar junction transistors or field effect transistors. These transistors cannot be used for signal amplification, but instead can be used as switching off transistors. UJTs have unidirectional conduction and negative impedance properties that make them act more like a variable voltage divider during breakdown. According to the equivalent circuit you see, the N-type channel basically consists of two resistors RB1 and RB2 placed in series with an ideal diode, D, representing a PN junction and connected to the center. Resistors. This PN junction emitter is placed in a fixed position along the ohmic channel during the manufacturing process and cannot be changed. Resistor RB1 is placed between the emitter and terminal B1, while resistor RB2 is placed between the emitter and terminal B2. Since the physical position of the PN junction is closer to the B2 terminal than the B1 terminal, the resistance value of RB2 is lower than that of RB1. If a small positive input voltage, which is smaller than the RB1 resistance voltage, VBB, is applied to the emitter input terminal, the PN junction of the diode will be negatively biased, resulting in a high impedance and the part will not turn on. The UJT is off and the current is zero. But when the emitter input voltage rises and exceeds VRB1 or VBB plus 0.7 V, which is 0.7 V equal to the voltage drop across the diode's PN junction, then the PN junction is forward biased and the UJT is activated. And as a result, the emitter current IE flows from the emitter to the base region. A single junction transistor is a trigger semiconductor device that can be used in a variety of circuits and applications, from lighting triacs and thyristors to use in sawtooth generators for phase control circuits. The negative resistance characteristic of the UJT makes this part useful as a simple relaxation oscillator.
MOSFET transistor.
The MOSFET transistor is equipped with three bases, source, gate and drain. By applying voltage to the gate base, the electric current between the drain and source bases can be controlled. When you press the key in your room, the electrical circuit is connected and the electric current reaches the lamp. So the voltage applied to the gate does the same thing in the MOSFET. Connecting the gate to the voltage source causes the resistance between the drain and the source to decrease drastically and create a channel for the flow of current from the drain to the base of the source. When no voltage is applied to the gate, the drain to source resistance increases sharply and the current path is lost. Classification of MOSFET. MOSFET transistors are divided into two categories, MOSFET enhancement and MOSFET depletion. In enhancement MOSFET, no channel is created in advance between the drain and the source, and by applying the appropriate voltage to the base of the gate, the current passing channel is created. The width of the channel depends on the voltage level applied to the gate, and as a result, the current passing through it can be controlled. In the depletion type, the channel is created by the manufacturer and by applying voltage to the gate base, we can change the width of the channel. While the enhancement MOSFET is by default without applying voltage to the gate base, the depletion MOSFET is connected due to the presence of the channel, and by applying a negative voltage to the gate base, we can reduce the width of the channel. In general, enhancement and depletion MOSFETs are made in two types, N and P, in which the current flows from the drain to the source, and in the P type, the current flows from the source to the drain. Application of MOSFET.
These types of transistors have wide applications in electronic circuits, and thanks to the advancement of technology today, we can put millions of MOSFETs in a memory chip or microprocessor. In addition, it is common to use this transistor as a voltage-controlled switch in electrical circuits. The MOSFET transistor is so important that without it, it would not be possible to make a pocket calculator and wristwatch. These transistors are used in making IC integrated circuits, CMOS circuits, analog switches, power electronics, MOS memory, sensors and quantum physics.
Transistors based on performance.
Small switching transistors are used for switching and sometimes in amplification. The amplification performance of these transistors is not very strong, but they perform better in the switch. These types of transistors are available in NPN and PNP models. The current required for it is 10 to 1000 milliamperes.
Power transistors.
Transistors used in high-power amplifiers and power supplies are called power transistors. There are transistors of this type in the form of NPN, PNP, and Darlington transistors. Their collector current is between 1 and 100 amperes.
High-frequency transistors.
RF transistors are used in high-speed switching applications, as well as for small signals operating at high frequency. RF transistors must be turned on and off at high speed. NPN and PNP types of high-frequency transistors are available in the market. These transistors have a current between 10 and 600 milliamps. High-frequency transistors are used in oscillator and amplifier circuits, such as CATV, UHF, VHF, MATV, and HF.
Application of transistors. Due to their different characteristics, transistors have found many and varied applications in components and circuits. Transistors are used to switching, power supply, voltage regulator and amplifier, oscillator and IC. These parts are used in analog and digital electronic circuits. In digital circuits, transistors are used in making various parts such as switches, logic circuits, memory such as computer memory, etc. In these circuits, transistors have the role of turning on and off the current. In analog circuits, transistors play the role of amplifying electric current. FET transistors are used to reduce the loading effect, i.e. in voltmeters, phase shift oscillators, etc.